In this example, we're going to try a little more practice with integration by parts. So if you remember, we have this acronym that helps us when we are choosing our U. And here, I don't see any logs, I don't see any inverse trig. X squared is algebraic and cosine x is trig, so it looks like x squared wins. So I should let my U be an x squared, which leaves me with a cosine x dx for my dv. To find du, we take du dx, which is 2x, and then we move that dx up to the other side. Sorry, this is getting a little crowded. And then to find v, we take the antiderivative of v, dv, and the antiderivative of cosine is, oh, see, there it goes, I said it would happen at some point, is sine x. No minus needed. Derivative of sine is cosine, so we don't need a negative. Okay, so there is my setup. And this tells me that my integral is equal to u times v, x squared sine x, minus the integral of v du. So that's going to be 2x. I'm going to go ahead and move the 2 out in front. Sine x dx. So I think I said this in an earlier one. There's a lot of trouble that can happen with negatives, and constants can get tricky as well. So I try to really get into that habit of moving those things out in front of my integral when I'm doing by parts. So comparing back, this is the check. Is it better than what I started with? And it's similar, but I would say it is a little better. I've knocked that power down by 1. And based on the last example, I'm feeling pretty confident that I can knock the x out completely if I do this again. And you can do it as many times as needed if you're trying to get rid of an algebraic factor. So now I'm going to let my u equal x, which means my du dx is 1, so my du is equal to my dx. My dv has to be everything else, sine x dx. I do care whether or not you're writing those dx's. If you leave them off, that's not good. V is going to be the antiderivative of dv, and the antiderivative of sine, let's see, cosine x is minus sine, so it's going to be a negative cosine. Okay, and when we put that together, we've got x squared sine x minus 2 times, and the entire integral is getting replaced with what comes out of by parts, so I'm going to bracket off my u times v minus the integral of v du. So u times v is an x times negative cosine, opposite of cosine, minus the integral of v, which is a cosine x, and I'm going to move that minus out in front. Really easy to lose track of signs, so just try and deal with them immediately. And this is looking pretty good. I'm going to go ahead and distribute. You can do steps in whichever order you want at this point. We need to distribute the negative 2. And then we need to integrate the cosine, which we have done already. That gives us a sine. So I have x squared sine x plus 2x cosine x minus 2 sine x plus c. And this is equal to that original integral of x squared cosine x dx. Okay, so by parts can absolutely be repeated. It works as many times as you would like to do it.